All right. Next round of notes here is about Riemann sums some more. Okay. Tables again. But the big switch over here, as you can see in the title, is that the widths of each rectangle is not uniform in the given table. So where, we would make nice rectangles that were all the same width before and do like a left end point or something like this. They're all the same width. How pretty. Now, we are going to, my eraser is humongous. So let's leave that as is. Okay. Now we're going to take that same area and we're going to put different size rectangles in here. So they'll still be left, but some might be skinny, some might be fat, some might be really wide, some might cover 3 intervals, some might cover 2, some might cover 1. They're all going to be different sizes. Okay? So that's what we mean by non-uniform. And you can see as you jump from one X value to the next that these are very different than the types of tables that we were doing in the last set of problems. Okay. Now the other thing is you see only 2 kinds of problems here. Page 1 is left-hand Riemann sums. And I guess the bottom half of this is right Riemann sums. And that is because when the heights are not uniform like this, think about why on this interval 0 to 3, we may not be able to do a midpoint, right? What value would we have to use for x to evaluate the midpoint, right? We would have to use 1.5 because that's in the middle of 0 and 3. But this particular table doesn't give us that information. So you will never see non-uniform bases and a midpoint problem together. That just doesn't happen. All right, so that's sort of good news. All right, let's go through here and let's do the first one together. So same idea. All we have about this function is these data points. We don't know what it looks like. So again, if you wanted to map out 3, 6, 7, 10, what this looks like, and you wanted to plot 1, 2, 3, 4, 5, 0, 3, the first point, 3, 2, the second point, 6, 3, the third point, 7, 4, the fourth point, and 10, 5, the fifth point, you could plot them out and look at this function. All right, so our rectangles then, right, for this, since they're all left end point, the first one would look like this, the second one would look like this, fourth, fifth, sixth. So we have, oops, I would go over here. We have the different widths as I was talking about before. So we just have to total up all these areas. But we also want to get used to the pattern that emerges when we look at a table for a left-hand endpoint. So these problems don't really give you an n value. Okay, there's really no n here. Because we can't divide by n for when we normally do b minus a over n because the bases aren't uniform. So there's no need for that calculation. And if you want the best approximation available to you, you will use as many intervals as there are in the table. So for this one, there are 4 intervals. So technically n equals 4, but we can't really make use of that. Okay, and the main difference in how we calculate base and height is that we're going to do each rectangle one at a time. So this first rectangle that I'm shading in here has a base of 3 units. That's the width, right? That's the distance between 0 and 3. And then it has a height of its left endpoint, which 0 is its left endpoint. So we're using that height of 3 for the height. Now let's do the next rectangle. Let's switch to this green guy. All right, well, his base is 3 units again, because that's the distance between 3 and 6. And his height is based off of the left endpoint 3 and the height at that point, which is 2. Let's do another one. Let's do this orange one. So what's the base of this rectangle? Base of 1 times its height, right, is determined from the 6, and the height at that point is 3. And then the last rectangle that we sketched, purple, has a base of how many units? 3. And then its height is determined again by its left endpoint of 7, the height at that point, which is 4. So instead of having this, whoops, and then all the heights, you know, added together, right? We can't do that any longer because this number is not uniform. We can't calculate that, like I said before. So we have to individually do this series of base times height plus base times height plus base times height. And then, of course, we have to come up with the answer here for the area under this curve. So this is 9 plus 6 plus 3 plus 12, which is 30, I think, 15 plus 15, right? So we get 30 for the first one. And the good news about this particular PDF here is that if you scroll down, it's 2 pages long, 2 pages worth of problems. Second half is all multiple choice. That's nice because you can see if your answer is there. But even better is we can go to the third and fourth pages are the answer keys. So we can see question number 1 is 30. So that one was done correctly. Okay, let's do another one a little bit faster. If I kind of make this pattern evident here, back in question number 1, sorry to go back in time, you again can see that we used all the heights that are on the left of the intervals, right? So we used the 3, the 2, the 3, the 4. We did not make use of 5 because this isn't a right-hand question. Let's advance to number 2 and let's try to do it without drawing a picture of it. And let's try to just make the calculations one at a time. So on this interval right here, right, the first interval is 1 unit wide, and then its height is 5. Okay. For the next interval, I'm going between 1 and 4, and I'm highlighting that 3 because it's left endpoint. So the distance, right, between 1 and 4 is 3 units for my base, and then my height is 3 units for that height. That was redundant. Let's go to the next interval. All right, let's look at the distance here between 4 and 8. That's 4 units, big base, and then multiply by its height of 4. And then the last interval, let's go purple. I've got the distance of 1 between 8 and 9 for its base, and then its height is 5. So totaling all this up, I get 5 plus 9 plus 16 plus 5. Looks like 35 is my answer there. Scroll down to check. Whoop, good job, self. Okay, so those are a couple of left-handed samples. Let's advance down here to numbers 5 and 6 where we see some right-hand work. So same idea as before. I'm going to kind of highlight those intervals one at a time. But this time when I highlight the information in this table that's important, see how I'm changing the direction? Because of the numbers 0 and 3, 3 is the right endpoint of that interval. So I have to make use of its height, which is 5. So I have 3 times 5 this time for my base times height, plus... let's see if I can do this on top of each other and you can kind of see it all together. The distance between 3 and 4 is 1 times my height is 3. Then the next interval is 4 to 6 and my height is 5. So that's 2 times 5. And then the last interval, whoa, we are not doing blue, is 6 to 8 with a height of 7. Okay, so that is 2 units for my base, right? Distance between 6 and 8 times my rectangle's height of 7. 15 plus 3 plus 10 plus 14. Oh, okay, 18 plus 24. Come on, brain, 42. Right, scroll down, check it out. 42. Life is good. All right, so let's do another one, same idea. 0 to 2 using 3. And again, maybe this format where you do all of this colorful work is helpful for you first. And then you do the actual calculations last, because this really helps you to set up the intervals that you're using. Oh my God. And then the heights that make sense with each one. So for my pink interval, it's 2 units wide with a 3 units tall. My green interval is 3 units wide, 2 units tall. And then my orange interval is 2 units wide times 4 units tall. And then very lastly, purple, 3 times 3. Okay, so I've got 6 plus 6 plus 8 plus 9. These are more like numbers you would see in a non-calculator part, something very manageable by hand. And I've got 29 there. All right, so why don't you do this? Why don't you try 3 and 4? Well, I guess I'll just set you off to finish all these pages. So complete the problems that are on this page, checking your answer, and then complete the work on page 2. You've got multiple choices down there at the bottom, so you know if you're on the right track. And then, of course, you still have the answer keys down below, so you'll know if you're doing it right.